Hello, and welcome to an introductory overview of CERES by Vlahi Systems. Vlahi's corporate tagline is Prepare, Respond, Analyze, Anytime, Anywhere, Any Device. And during this presentation, we will showcase key aspects of CERES developed specifically to help fulfill that purpose. CERES stands for Chemical Emergency Response, e-Service. It's a decision support tool that helps you prepare for chemical emergencies by supporting training, tabletop exercises, and live drills with predefined scenarios, then facilitating response in real time by integrating live meteorological and gas sensor data with models and advanced algorithms to monitor, track, and analyze the impact of toxic releases, fires, or explosions. Then, post-event, during a debrief or a hot wash, CERES provides the ability to go back with archived data from the incident scene to be able to reconstruct and review the sequence of events and actions to help determine what opportunities exist to do things differently to help improve outcomes. CERES is a cloud-based software as a service or SaaS application. It will run on any device, whether it be Windows-based, Mac, Android or iOS, and does not require any installation or updates. For smartphones, we have also developed native applications to further improve the user experience due to the smaller form factor. But make no mistake, anything that you can do on a PC or a Mac on a larger screen, be it remote access, sensor monitoring, modeling, plotting, reporting, and sharing, it can all be accomplished on a tablet or a cell phone. This is a heat map of our global users. At the time of this recording, their numbers were approaching 9,000. This includes a wide-ranging global base of individual users, hazmat teams, and a growing list of corporate and government clients. These include customers like ICL Group, the world's largest manufacturer of bromine and bromine-based products, and Nutrien, the third largest anhydrous ammonia producer in the world. PISAT, a global satellite operation and application service provider, FIAP and Adelphas, a European Union project in support of the safe transportation of dangerous goods in North Africa. Then ESIM, Takeda, Borealis, Nufarm, and others, all part of the Chemipark facility in Linz, Austria, under the protection of the park's fire protection and EHS services, along with a growing number of hazmat and CBR&E teams from North America and Europe, as well as consulting firms in North America, Asia, and Australia. Rounding out the user base, we have a few WMD CST teams in the US user group, and Canutech, Transport Canada's Hazardous Materials Emergency Response Center. These entities all have a vested interest in effective response to hazardous materials incidents, and now they use CERES to help them plan and prepare for and manage those situations. The tools they access in CERES include government-approved models and guides to help evaluate the effects of toxic and flammable gas clouds, levees, and jet fires, and the overpressure and thermal radiation from fires and explosions, as well as the ability to develop the source terms associated with tank, pipe, puddle, and direct source releases. CERES also incorporates the Railcar 4 model, which emerged from the Jackrabbit experiments by the TSA, DHS, and DoD in the aftermath of several large train derailments in the early 2000s. Railcar 4 allows the users to better estimate the source strength associated with pressurized liquid releases under certain environmental conditions when they form stationary clouds or mist pools. The system detects those conditions and recommends that the user apply the Railcar 4 model instead of the standard modeling procedures. We also incorporated the Kingery Bullmash TNT blast equivalent model to estimate the hazards associated with solids like an ammonium nitrate fire. Think Toulouse, France, the Beirut, Lebanon explosion, and closer to home, West Texas, and so forth. You can model these types of events by simply entering the inventory at risk, and CERES will plot the estimated overpressure effects, safe standoff distances, and recommended public evacuation zones. To further support the hazmat side of things, there's a full and complete integration of the ERG 2020 that includes the hazardous materials distances associated with small containers, transport trucks and rail cars, whether a fire is involved or not, and also consider if it involves a daytime or a nighttime release. The potential effects and recommended safe distances related to IED threats or levy and incident effects can also be plotted and reported, all from the ERG charts and guides, all selectable and viewable in the UI. For emergencies associated with natural gas pipelines, the system can also plot the recommended standoff and evacuation distances and list the sensitive receptors within those zones. Now, by design, CERES is a standalone application that can be up and running right out of the box, with government-vetted models, global access to live IBM weather data, and the ability to track existing GPS-enabled devices and cell phones and use manual sensor data. Customers can be up and running literally in minutes. But if you're one of the teams that have a local meteorological station or gas detectors, CERES integrates live data into its calculations. To that end, CERES can be connected to a wide range of devices like Met stations from Campbell Scientific, Vaisala, and WeatherPack, fixed sensors like Gastronics through a slate of data acquisition protocols like Modbus and OPC and PyServer and others, and GPS-enabled devices like cell phones and tablets or fleet tracking devices that might be on your response vehicle. What might be of specific interest is the CERES Tracker smartphone application, enabling responders or employees and contractors on a plant site to have their location identified during an event to help automate head counting, identify those at risk, help focus on the last known location for rescue and recovery, and improve response to the most critical situations. Every CERES system above the base level includes access to IBM Enhanced Weather. That provides live, current, hyperlocal meteorological conditions anywhere on the planet. This advanced version has access to hyperlocal forecasting, so you can define the potentially affected area for extended duration events. You can set a time frame and model the impact of the event in the future to better assess staging areas and evacuation zones based on weather changes that might be occurring in the future when you suspect the event might last beyond the current modeling time horizon. Down the right side, we've got access to wireless GPS-enabled gas detection capability from manufacturers like Blackline Safety and Honeywell. In this case, we're showing the G7 Personal Monitor and the G7 EXO, along with the AreaRay Pro from Honeywell. However, when discussing connectivity, our goal is to be sensor agnostic. If you have a suitable device that you're happy with, we'll do our best to work with you to integrate it into CERES. Now, in 2021, Vlahi partnered with Blackline Safety, and in 2022, the partnership was awarded the OHS Magazine New Product of the Year in the Emergency Response category. The partnership has resulted in a seamless integration with Blackline devices, featuring cloud-based LTE communication, no sensor configuration required, automatic correction or response factor application for PID and LEL sensors, and it includes the sector-leading molecular property spectrometer or MPS flammable gas sensors and extended battery life for their personal and area monitoring devices. To visualize all of this, the CERES UI is presented on a Google Map background, which is overlaid with custom GIS imported from Google, from your facility or municipality or third-party suppliers. And this can include neighborhoods, industrial plant perimeters, rail lines, release sources, tanks, and so forth. CERES includes live traffic to help identify open versus congested zones en route, as well as corridors that might be affected by the event and require assistance. The system includes sensitive receptor data from Google like churches, schools, hospitals, daycare centers, police stations, fire stations, and such, and can integrate your Tier 2 or other community risk assessment data as represented by the red icons. Now, take this wastewater treatment plant, for example. We've captured the name of the facility, their contact information and address, and the inventory associated with that site. And depending on the available data, this section can include site maps with additional plant information. When inventory data is imported from emission sources, CERES generates worst case and alternate case scenarios accessible by the user to be able to model the potential threat on the way to the incident before they even arrive. This can help establish the best approach to the incident scene, the extent of the hot zone, safe staging area locations, downwind and perimeter protective action zones that minimize the risk to the responders and help support the development of strategies and tactics. In this example, we're showing our downwind corridor connected live in real time to a fixed or mobile met station or the IBM Enhanced Weather Data Source. The amplitude of the cone is determined by the stability class. So, if we have a very stable environment, the cone will get narrower, such as during a nighttime event. And then during the day, when things are less stable due to daytime heating, the cone width will broaden. The corridor also includes 5-minute time rings associated with the wind speed. If the wind speed increases, the rings will spread out, and when the wind speed decreases, they will get closer together to provide a visual reference for the distance the wind will travel after the incident start time. This all comes together with the CERES model output, plotted with wind confidence lines, and all the sensitive receptors like churches and schools and hospitals, etc., or any custom receptors or zones are listed in the report, along with their proximity to the threat, and they can all be identified with a single click. The reports provide expected time of impact, the severity and duration of the exposure, infiltration plots for shelter in place or evacuation analysis, all in support of better decisions and recommendations. Across the bottom, you'll note some colored indicators highlighting non-sensor tracked devices. If you have a cell phone with the CERES tracker activated, or if you have a fleet tracking device, or even connected tablets on response team vehicles, they will be displayed on the map in this fashion. In addition to providing an improved operational picture of the incident scene, all tracked devices are managed as custom receptors to track their proximity to the threat. If they're inside the downwind cone, or the plume plot, or any hazard zone or recommended protective distance, these devices will be included in the report to further facilitate the protection of responding assets during the event. And in the case of an industrial facility, this approach can support accelerated site headcounts, as well as last known location data to help focus any rescue and recovery operations. Now, taking this beyond the mapping tools and the modeling engines and integrated monitoring and tracking technology, the Vlahi team has developed the final piece of the puzzle, the CERES sensor-driven algorithms. In this case, the source location identification and the sensor-driven plume algorithms. If an odor is reported or a release occurs, we can leverage live data to help respond to the situation. The wind cone can be inverted to identify the area or pre-identified zones, process units, or tanks that may be the source of the detected concentrations. Fixed or wireless GPS sensors can be used to stream data from the scene, but handheld detectors or even gas detector tubes can also be used. This will light up the pre-identified zones based on their chemicals to help ID the source on a plant site, and additional sensors can be deployed or samples collected in a community setting to move upwind and narrow the search area. Once the source is located, one more click and the sensor-driven plume or SDP is launched. With the sensors, chemical and med data confirmed, CERES uses the measured values to extrapolate the release rate required to cause those concentrations to occur, removing the need to characterize how large the vessel is, how big the hole is, or how much product is actually being released. Modelers the world over understand that this is the holy grail of live emergency response plume dispersion modeling. So for the end user, with CERES, they get a premier, feature-rich, live data-capable decision support system with an intuitive user interface at a very competitive and cost-effective price point. In the end, they'll have the tools to make better decisions, respond safely, maximize their resources, and reduce their response time. We'd like to thank you for your time today, and we look forward to seeing you in the future as we continue to explore the features and the capabilities of CERES and the way that it can be applied to help improve the performance of your emergency operations and emergency management organization. If you have any questions, or if you would like a demonstration for your facility or for your hazmat team, please reach out to us at sales@vlahi.com. Thank you.